What is it really like to be an AWS engineer? And by saying AWS engineer, I do not mean an engineer that works at AWS. I mean an engineer that builds stuff using AWS technology. In this episode, we're pulling back the curtain on the day-to-day, what they actually do, what makes the job interesting, and why so many people are going after it. If you're curious about this career path, this video is for you.
So Paloma, I have some questions for you. Now, what does a typical day look like as an AWS engineer?
So as I mentioned, AWS engineers basically build infrastructure that is deployed in Amazon Web Services or AWS. These can be applications that run on EC2 instances, which are servers in the cloud, or it could be managed technology. So basically technology where the team using it is a bit more hands-off. So a server, you have to take care of it, you have to patch it, you have to set up, configure things on it. But AWS and all cloud vendors have managed technology that allow you to just focus on writing your code, on doing what your application needs to do.
So you mentioned something on the intro. You said you can work with AWS, but not necessarily work for Amazon specifically.
Yes.
Tell me a little more about that.
Okay. So if you work for Amazon, you're an Amazon employee, and you could be an AWS engineer at Amazon. But most AWS engineers work for other companies that use Amazon Web Services.
Yeah. I think that's very important for people to understand. When you are, when you get training on AWS, most likely, in fact,
you're not going to work at Amazon.
You're not going to end up working at Amazon.
Yeah.
You're going to be working with Amazon
customers,
but not necessarily at Amazon.
Yeah.
So the other question is, how do you stay up to date and remain relevant for your job?
Okay, that's a good question. One of the ways I do it is, and I see a lot of people do it, they let reality dictate what they need to learn. So if your work environment is taking a certain route, you want to learn about the technologies that support that environment. Why? Because it's going to be easier to learn. Like, you're going to learn the conceptual stuff, you're going to put together perhaps a lab or something, or you're going to work in a sandbox, and then you're going to have actual workloads that become production that use these tools. Mm-hmm. So that's a way to kind of let your job give you experience and knowledge. But there's also a more proactive look at where the industry is going. And if I hear that the monitoring tools are changing, then I should start looking at that. So as an AWS engineer, you are constantly learning because AWS is constantly changing. One of the craziest thing with AWS is that they are the cloud that has the most services and features. So there's a lot more wiggle room on how to do things, and you have to learn about all these possibilities so that if you encountered a similar situation, you could leverage what somebody else has done, perhaps.
But let me ask you, how do you, because you said it, there's so much coming at you, there's so much changing. In your case, talk to us specifically. How do you systematically decide, okay, this month, this week, or this quarter, this is what I'm going to focus on improving, focus on learning more about, like you said, not letting it happen to you, but being intentional. Walk me through your system.
Okay, so
what works for you?
I advocate for both things happening. You have to be proactive and look ahead, and you also have to learn things that serve you in your environment. So proactively, what I do is every year I say, okay, I'm going to learn X. So for instance, this year I'm trying to get a certified Kubernetes administrator cert. That was something that I was going to do despite my job. I don't care if they use it or not. It's like the path that I chose for myself. And it just happens that at work we're using this technology. We're using EKS, so it's Kubernetes in AWS, and that's gonna help me get way more experience and knowledge in general. So that works. But let's say if I encounter a problem, and this happened to me at the beginning of my career, like I was working with workloads that used SSL certificates. I knew what an SSL certificate was. I didn't really understand how it worked. So if I figure out that I'm troubleshooting an SSL cert and I don't completely understand how it works, my job should be to go that same evening, that same weekend, and try to find some videos, find a book, find some content online. There's plenty of information on all these things.
Yeah. Okay, I get it. So it's a balance really of staying relevant for the time being and also looking at a longer term horizon. Okay. So another question we get a lot is, how do these challenges serve as opportunities to learn new skills and improve your process in general?
I like that about improving processes because that's something that I'm really proactive about. And this is probably a trade secret. Like, if you want to move up, you have to get good at documenting.
Why?
Because most people don't do it. A lot of engineers think that the code explains itself, and that's not true. So the code can be there, but we can have a million lines of code. What do I do every time I need to add a new account? Is that explained somewhere? What do I do if an application in one account needs to talk to another account using AWS feature called private link? Or is it a VPN connection? Whatever it is, like, we need to explain the business processes that our code serves. And that's going to be something that humans do. Not even AI can come and serve this process.
Okay. All right. So I have another question for you. In what ways do unexpected issues help build your problem-solving abilities and resilience?
Okay. That's interesting. When something breaks, we have an opportunity not only to solve that problem, but to solve it in a way where we can prevent it from happening again. Because one of the things that you all assume, especially the ones that are not in tech yet, is that nothing breaks at Google.
But I think it's so wrong to think about that, because that's what you get paid for.
Yes, that is the objective. They pay us big bucks so that we can prevent things from breaking, so that we can prevent bad actors from doing things to our systems.
And when they break, to fix them.
Yes. So the expectation is that the first time that we build it in a way that if it breaks, at least another copy of that workload can continue to serve the purpose. So there we talk about high availability, we talk about redundancy. Let's talk about this outside of pure tech.
Technically.
So let's say you have a data center or you have a hospital. Can your hospital only rely on the electricity that comes from the main grid? That would be dangerous, right? Mm-hmm. Because if there's a storm and the power grid is affected, then if somebody's performing a surgery in there, they're gonna have major issues. People that are on ventilators are automatically not gonna have any possibility to breathe, right? So having that second form of power, sometimes even a third form of power, allows that organization, or let's say the hospital, to continue serving its mission. So they already acknowledge the fact that that's a possibility, and then they have redundancy to make up for that. Yeah. So the same thing happens for tech infrastructure. We have to build redundancy. We have to build for high availability, so that if something does break, maybe another one can come up quickly. So in the world of AWS, you have auto-scaling groups. You use multiple availability zones, so that even if something happens to AWS, not even to us directly, in one data center, we can continue to operate from a different data center. So going back to your question about how these unexpected issues help us with problem solving, well, the first time it happens, if we didn't build for that because of cost, because of technical, something technical that lacked there, we can use that opportunity to learn, hey, this happened because we weren't present in 3 availability zones. So 2 availability zones went down, and all of our stuff went down. So now we need to expand this to 3. Or maybe we need to build a disaster recovery solution in a completely different region. So most of the time, both companies and us as professionals, we learn from problems. In the tech world, there's even something called tabletop exercises or disaster recovery exercises, where they proactively do a practice run on what it would take to recover from an issue. And sometimes there's even a little bit of chaos engineering in there, where like they don't tell you what's gonna break.
Yeah.
You have to sort out whatever is breaking. One thing that I've used and that is really, really fun once you're in the field and even as you're studying, is to go to like DevOps game days. These are educational events where you basically are challenged to solve different situations or deploy things in a certain way. And that pushes you to think like outside of what you do on a 9 to 5, because for instance, every environment is going to be different. And that's something I'm not tired of repeating to our students and in these videos. No 2 environments look the same. We could have 2 companies using AWS, their choice of services, their choice of deployment methods, all the tools that support that environment could be completely different or like interconnected in different ways. So don't expect that whatever worked for me is going to work for you. So when you go to these exercises, it's like these DevOps games, you gain experience because you're learning how to operate in a different situation.
So lastly, what are some additional skills like automation, containerization can give you a competitive edge in today's market 2025?
I would say any. You choose one and you go deep, and you're going to be able to build some specialization. Right now, in cloud, you have to automate. Nobody is hiring you to go click on things on the console. If you're not able to use an automation tool for deployment like Terraform or Pulumi, it's going to be hard to find a job. Also, if you're not able to script things, let's say to install an agent or something that a server needs through a user data script, that's going to be a big lag in your experience. Also, if you can't figure out how to write a simple Python script that can be used in a Lambda function to do something repetitive that doesn't need like a human to do it every time, that's also gonna hurt you. So knowing these things can future proof you, can of course make you more time proof. Yeah, more future proof you, sorry. Containerization is what we're at now. 5 years ago, 5 years ago, a lot of applications still ran on EC2 instances directly. Now we're seeing that things are shifting and we're having like half and half. Some environments, especially startups, are trying to use more containerization because it's cheaper. So companies that are building things right now that have less technical debt are just going to the most modern form of technology.
Okay.
So my advice, if you're trying to become a AWS engineer, is that you are really proactive about learning. And how you can do this, you can stay up to date by consuming content about these tools. The different vendors, they're very good at keeping good documentation. Go to places like Medium to see articles of people that have solved specific problems, or like just read about the problems that they have, which may not be the ones you have. Go to conferences. These conferences will open your eyes and you'll see like all these different solutions that others have built. Go to meetups, and above all, set a path for yourself on what's the next big thing you're gonna learn, and also learn from your own environment as much as you can, because that's what you'll be able to go deeper into.